Hi, this is Koiro, and this time it's the C64 Resurrection Part 8.2. As episode 8 was the 1581, we are continuing with the 1581 today. And I was thinking of waiting until I get all the parts before I did this bit. But there is a lot of people asking me, did you even get this one to work? And I think I have to answer that in a video. So what we are going to do here is that we are actually going to test the 1581, even though we cannot fit it in the case at this time, because the ICs that I've made replacements for are too big to fit in the case. And that is also the case with the capacitor that I've placed on the additional power supply. So I have to change that into a smaller one, and I have to get the 7407 replacement chips. So let's just get started. First we test the 1581 to see, does this work? To test the 1581 I use my trusty old C64C with the 2404 66 board. And this was a machine we tested to be okay in an earlier episode in this series. And I will just connect this with the serial cable and the power, and I also connect this to my video grabber so that you can see on screen what's happening. I learned back in the days that you turn the drive on first and then the computer, and it's anyway good to have the serial bus synced. And there the C64 is on, and this floppy I'm using is an old Amiga floppy from a magazine, and I formatted this on an Amiga just some time ago, so I know that this floppy actually works. The dip switches on the 1581 is set to device 8, and this command actually opened a command channel 15 to the device 8, and it communicates with the drive, so we know that the drive is answering on the bus. And we just close this channel again, and then we'll try to initialize or format this disk. A simple format command was not the way to do things for Commodore. They actually have this command where you, or this structure where you send these commands to the drive, and the intelligence and the computer built into the drive actually performs this for you while you wait. So that's why you get the prompt back. It's no waiting on the keyboard while you format the drive, and there is no communication back from the floppy station when the format actually is complete. So this takes about a minute or so. So what this command actually does is that it opens a communication channel, channel 15, to device 8, and it does the command new drive, where it tells the drive to have the label Koiro as an ID on the floppy, and it just sends this to the drive, and we just have to sit back and wait for the drive to stop making clicky noises. That is the sound that the drive makes when it's changing tracks on the drive. As you can see, I'm using my custom chips while I'm testing this, both the 7407 and the clock chip. And I actually got a 7493 chip. It's not the LS version, but this will actually work here, I think. It has a bit more power draw, but I think that will be good. 1 minute is an awful lot of time, so I fast forwarded a bit, and now I just try to load the directory from this floppy to see that it actually is initialized and works. And we can see that it does. The label is Koiro, and you have the 3160 bytes free. So we just try to type in a small basic program and save it to test the functionality of the drive. And here I did the real lamer error. I forgot to new before I typed in the basic program, so I got the line numbers 0 with the label and 3160 blocks free as line numbers in my basic program. To save to a floppy is quite easy. You just add the .8 as the device number after the save command, and then you save to the floppy instead of the tape recorder. And the same with loading, you just add the .8 after the file name, and you have to enter the file name inside the quote marks. And you can of course cheat and use wildcards as asterisks for the first file on the disk. And this is the exact one moment where it hits me that I forgot to new before I enter the basic program. So I actually have a line number 0 that will prevent the program from running, and I have the 3160 that will not affect the program at all because I have a goto inside there that runs this in a loop. And this very simple piece of Petsky artworks never fails to amaze me, but we have to break it anyway to make a further test. So I will just type in a simple program from the 1581 manual. That is the program that is used to read out and verify the status of the drive. And if the drive fails and there is an error code, this is the way that you can read this out of the disk drive's internal computer. And it's always good practice to save your program before you try to run it. And when I run it, I discover that I this time did not use the new command either, so I have the 3160 blocks free line still in my program. So to quickly hide my error, I remove the line and I save the program again under the same name. And here you can clearly see the difference between BASIC doing a command where the prompt freezes while the file is saved to disk, and when the drive is performing the operation as it does with an initializer format. And since this is the day of noobs or lamers evening on the C64, I of course had a typo in the file name when I saved this to disk, so I loaded the directory to see what the file name actually is. So with that minor details sorted out, we load the program, we run it, and then we see the stats of the drive. And what we see here are the info from the error channel on the drive, and it's the error number, the error message, the error track, and the error sector that is displayed. So our 1581 drive is clearly functional and works to the test that we have put it through. But the whole construction looks a bit unorganized, and that we have to do something with. This case is a case that is bought via the Print It Yourself service from the Core i64 web page. And I had a friend of mine print this out, and the result actually get quite good. So I do think that we will be able to fit this in the case. The Print It Yourself kit also comes complete with a bracket for the drive. And this is for a standard 3.5 drive mechanism. There are some horizontal stripes from the 3D printer, but I do think that this will look quite good if I just brush it down a little and paint it. This print is meant to use 2mm heat inserts to fit the screws, but I don't have those, so I will just use ordinary screws. My biggest concern on this is that my custom ships won't fit in this design because they are too high and will just touch down or make it impossible to fit the floppy drive. The case follows the normal profile and it fits the card real good. It does have a slight difference in the profile on the sides, but both on the bottom and on the back the card fits in rather nicely. But the problem arises with the bracket that should fasten the floppy drive to the case. And this is a really good piece of plastic, it's well made, but you can see that my custom ships is too high. And I also think that the capacitor I mounted for this power supply also is too big for the bracket to fit okay. Since I also have the adapter board, I think the cable management and fitting the cables for the floppy drive will be a tight fit. I will try to see how much space I really have with the real floppy drive in here. I do think the bracket is an excellent design with the adjustment holes and everything, but I do worry that this will trap a lot of heat because it takes up a lot of room in the device and also right above the ICs that gives away heat. But one thing is for sure, I have to redesign these brackets or I have to wait until I get the proper ICs before I can mount this. The front cover is the biggest change from the original 1581 design, where this is designed to have the normal front bezel of a floppy drive pointing out through the front. My friend actually printed 3 different versions of the front bezel, each of them with a different surface pointing towards the extruder on the 3D printer to see what gave the best result. And as usual, it's a trade-off between flat surfaces, support scars and sturdiness. And I just picked the ones with the best surface that also seems to fit the tabs that should fit into the bottom piece the best. And when I put the floppy drive and bracket in place, I can see that I am about 4mm too high to get this to slide in, so that's another proof that we have to wait for the proper ICs. I have now got the power plug, or not plug but connector for the 1581 board, and this is the right kind. And here you have a power plug for power adapter for 1541-2, and it fits right in. So I'm going to solder this in, and then we have one more piece that is completed on our board. And I also have a 7493, not the LS, and I will try this on this ship. The danger is that this crystal canned oscillator will not be able to deliver enough power for that. But that is something we really have to check. I just disconnect these bits and pieces to be able to push this onto the board when I solder. Big holes, so I need to fill them with solder, like so. Then I will try the 7493 ship. It seems like I have to bend the legs a bit, as this is a new ship and it has never been in a socket before. And then I will just connect the power to the internal power regulator, and I will also connect the LEDs to see the status of the power on the board. And I turn it on and I study the LEDs, and the video here is lying because both LEDs are on in a short moment and then it's just the red LED that is on. But this don't show up very clear on the video. I will now connect up the scope probes to probe the signals to see that the circuit is getting the signals that it should. So I just connect up my Regal scope, and the QB is 8 MHz and it's a perfect square, so that's a good result. And I will also check that the crystal oscillator input is okay, and that is a perfect 16 MHz square, so that's even better than it was before. And QD should be 2 MHz, and that it is. So this looks like a perfect result, so we can keep this 7493 in there, even though we might change it for an LS version later. So then it's just the 7407 chip that's left to change, and I don't have a delivery time for that, so I'm going to finish up this video without that in place, and we have to just wait for that to arrive in the mail. So that's about wraps this up for this video, and I do think we have learned something in this video. We actually learned that this terrible piece of engineering here could be replaced with a 7495 and that the circuit works perfect with that. We did learn that the bracket stands in the way for this, or this stands in the way for the brackets is a more right way to put it. But also the plug for the power supply might stand in the way. And we do have a bit of a space constraint here, so I might modify a PC drive to work without the adapter board to make cable management possible here in the back. I did get the proper power connector, and we have tried the drive, and this drive has worked perfectly with everything I have thrown at it. I have tested this now with 2 PC drives that works totally fine, so I do know that it works across several types of floppy stations. So will I make a part 4? I'm not really sure, because I only have to change the components and put this in a box. I might make a short 5-minute video about that when I get the 7407. So please hit like and subscribe if you find anything interesting in my videos. A subscription will really help out the channel. please leave a comment if you have something to comment about the contents or future topics and whatever. So, thanks for watching, see you in the next one.